Okay, let's talk about something that's literally all around you. Right this second, but you can't see it. It's an invisible force that powers your phone, warms your skin, and even creates the colors of the world. Ready to dive in? So let me ask you something. What could your cell phone, a bad sunburn, and the color blue possibly have in common? It sounds totally random, I know, but it turns out they're all connected by a fundamental force of nature. Stick with me because it's all going to make sense.
It's pretty wild to think that for pretty much all of human history, light, the very thing that lets us see the world, was a complete mystery. We lived by it, we depended on it, but as one of our sources says, we had no idea what it really was.
And that's because the real answer to our question isn't just about the light we can see. Oh no. To really get it, we've got to look at the entire invisible spectrum of energy all around us. Okay, so here's the big sciencey term for it: electromagnetic radiation. I know it sounds super complicated, but really all it is energy that travels in waves. The truly amazing part is that things that seem totally different, like the radio waves that bring you music and the x rays you get at the doctor's office, are actually the exact same kind of energy. They're just vibrating at different frequencies. And this is the whole family photo. It's called the electromagnetic spectrum. Think of it like a giant cosmic ruler for energy. Over on the left, you've got these long, low energy, kind of lazy waves. But as you move to the right, the waves get shorter, faster, and way more energetic. All right, you ready? Let's take a quick tour across this thing. I think you'll be pretty surprised how much of this invisible world you're already using every single day. Okay, so let's start way over on the left with the super long chill waves. We're talking about radio waves. Their long wavelength makes them perfect for carrying signals over huge distances, which is why we use them for, radio and all sorts of other communication. Now, let's turn up the energy just a little bit. Next up, microwaves. Yep, the same kind that heats up your leftovers. But that's not all. They're also the waves that make your cell phone work, what powers your Wi-Fi connection, and even what radar systems use to track planes and weather. Moving on, we've got infrared. Now, this is the one you can't see, but you can definitely feel. Infrared is basically just heat energy. It's the warmth coming off a toaster, it's what your TV remote uses to send a signal, and it's how night vision goggles can see things in total darkness. And now, right here in the middle, we get to this teeny tiny little sliver of the spectrum. I mean, look how small it is. This is it. This is visible light. Out of that entire massive range of energy, this is the only part our eyes have evolved to see. Every color you've ever seen, from red to violet, lives right here. Okay, so just beyond the colors we can see, we run into ultraviolet light, or UV for short. This is the stuff from the sun that gives you a tan, or, a really painful sunburn if you're not careful. But it's not all bad. It's so powerful that we use it to kill bacteria and sterilize equipment. And it's even how special lights can spot counterfeit money. All right, now we're getting to the really high energy end of the spectrum. These are the heavy hitters. You've got X-rays, which have so much juice they can zip right through soft stuff like skin, letting doctors see your bones. And then, even more powerful, gamma rays. These are so strong, they're used in radiation therapy to target and destroy cancer cells. Just wow. Okay, that was a lot. So how in the world are you supposed to remember all that? Well, there's a pretty clever little trick. Just remember the sentence, Raleigh man invented very unusual X-ray glasses. Each word stands for a part of the spectrum in order. Radio, microwave, infrared, visible, ultraviolet, X-ray, gamma. Simple. So now we know what this energy spectrum is, but where does most of it come from? Well, for us here on Earth, our main source is that giant fusion reactor in the sky, 93 million miles away, our sun. It's constantly bathing our planet in this energy. So when you look at all the energy the sun sends our way, what are we actually getting? Check this out. Almost half of it is infrared. Yep, that's just plain old heat. Most of the rest is the visible light we see every day. And that little 7% slice, that's that powerful ultraviolet light. Okay, so the sun blasts all this energy at us. What happens when it actually gets here? Well, right off the bat, about 30% of it just gets reflected straight back into space by things like clouds and shiny ice. The atmosphere itself kind of soaks up another 20%. That leaves, you got it, a full 50%. Half of all that incoming energy gets absorbed by the land and the oceans, heating up the surface of our planet. And that absorbed energy, that's the real key to this whole story. It doesn't just disappear. It powers a system that basically makes our planet livable. We're talking about the natural greenhouse effect. And just how important is this? I mean, really? Well, listen to this from DW News. Without this natural effect, the average temperature on Earth would be a crazy cold -18 degrees Celsius. That's about 0 degrees Fahrenheit. Our world would be a frozen rock. So yeah, it's not an exaggeration to say we literally wouldn't be here without it. So why call it the greenhouse effect? Well, the analogy is actually perfect. Our atmosphere works just like the glass roof of a greenhouse. It lets all that high-energy sunlight stream right in and warm things up. But when the ground tries to radiate that warmth back out as heat, the atmosphere traps a lot of it. It's much harder for the heat to get out than it was for the light to get in. Let's just walk through it one more time in 3 simple steps. Step 1. Sunlight shines through the atmosphere and warms up the Earth's surface. Step 2. That warmed-up Earth radiates the energy back upwards, but now it's in the form of infrared heat. And the crucial step 3, certain gases in our atmosphere catch most of that outgoing heat, kind of like a blanket, trapping it and keeping our planet warm. And the result of this amazing, perfectly balanced system? A nice, comfy global average temperature of about 15 degrees Celsius or 59 degrees Fahrenheit. It's that Goldilocks temperature, not too hot, not too cold, that has allowed all the incredible life on this planet to flourish. So you have this natural energy blanket, right? And it traps just the right amount of heat to keep our world from being an ice ball. Which brings us to the big, final question we have to ask ourselves. What happens if we start making that blanket thicker? It's something to think about, and it really shows you just how delicate this whole invisible energy balance really is.